Hey guys, it's Mr. Zimmerman, and today we're going to expand on the idea of the inverse of an exponential function. So go ahead and take the opportunity to look at the graph from last time and notice how we do not have an equation for the inverse. We represented it with, let me show you this new format of, hey, an inverse is a function written to a -1. It is not talking about the reciprocal as in numbers, but it's talking about the reciprocal of the function where x and y are swapped. And notice how the base function right now is blue. Take a notice of the key characteristics and some of the key characteristics of the inverse. Notice how the x-intercept is 1, 0, and how that's the opposite of the y-intercept. Notice how the function of the exponential has an asymptote at y equals 0. And notice that the inverse, the red graph, has an asymptote at y equals 0. This is just true for the inverse of an exponential. Notice how everything is linked, everything is connected. This idea of a function, one input, one output. Now we're playing with the idea of changing that, where we give you the output and you give me the input. Now let's go ahead and dive into the new stuff. So what we're going to look at right now is f of x is b to the x. B is the base, and then the x is my input. And basically what happens, I know it's going to be growth because b is greater than 1. The base is greater than 1. So we need the inverse of this. Well, let me go ahead and try to find the inverse. So I know that my function, I switch my x and the y, and I get x equals b to the y. Now, I don't necessarily know how the heck I'm going to be able to do this. If it was x equals 2y, I would divide. I would multiply. I would add. I would subtract. Now here, you might think, oh, I got it. Last unit. I'm going to take the square root of x, and I'm going to take the square root of this side. Okay, this is going to be the same because nothing happens, but I know that since this is a y and a y, I know that a radical is the inverse, so it's going to be b. Okay, but I still don't have it. I do not have y by itself. Right now, y is in this weird spot. It's the index. And notice this is something else that's weird, is my input and my output are on the same time. So what? I need to get y by itself. What the heck? So essentially what I'm missing right now is the inverse of an exponent. We're going to have to invent a new inverse. I know that the opposite of addition is subtraction. Subtraction, addition. Multiplication is division, and division is multiplication. Easy peasy. We've expanded upon that. We know that the opposite of a number to a power, let's say 2, is the square root of that number. Now, if I go ahead and take that number to the third power, my radical is going to change as well. But I don't have a way to get rid of that y out of the exponent and not have it be more complicated. This is not even a function. No, thank you. I don't want to deal with that.